Okay, so this is the basic sine curve. If you remember, our points are 90, 180, 270, and 360. Go up to 1, down to -1, 10 miles right and 2. And the coordinates of point P, therefore, are 180, 0. It's 180 on the x-axis, 0 on the y. And Q is 270, -1. Sketch the graph of tan. So again, your main points are 90, 180, 270, 360. At 90, there's an asymptote, and at 270. And there is no maximum, so this is what the graph looks like. I'm afraid that's just a case of remembering that. Okay. Solid metal cube has length of... Okay. So if our cube is what we're starting off with, if that's correct to three significant figures, then we're going to find, we always go to the next level of accuracy with limits of accuracy. So the lower bound would be 124.5 and the upper bound would be 125.5. If you remember, we say 125 add a 0. So it's 1245, 1255, and then put the decimal point back into where it should go. So that's our lower bound and upper bound. So we're making spheres. Of each sphere is to be 140. So what we're going to do is divide this upper bound. Sorry, we're going to divide our volume of our cube. Oh no, we need our side legs. I apologize, we need to find our volume first. So our volume of our cube, we're going to use the upper bound value because we want the biggest one possible. So it's 125.5 cubed. Although that's in millimeters, we want centimeters. All right, change that to be centimeters. So that's 197666. 1976.66. Okay, so that's our maximum volume for our cube in centimeters cubed. I didn't really explain all those bits, so hopefully you knew it's cubed and changing, because millimeters to centimeters you divide by 10. Okay, hopefully you'll write that. So each sphere has to be 140 correct to the nearest 10. So again, we want to find our limits for our volume of our sphere. So if we've got 140 to the nearest 10, so that means this the digit that's been rounded. So we don't need to add zeros because we've already got one. So our lower bound is 135 and our upper bound is 145. So because we're dividing, and we want to find the greatest number of spheres, we want the biggest volume of the cube and the smallest volume of the sphere. So we're going to do 1976.66 divided by our smallest sphere option, which is that. So we're going to divide that by 135. And that gives 14.64. So our greatest number of spheres we can make is 14. Now obviously we can't make the 0.6, so it would be 14. Now you may have had that answer, but not, if you didn't have this correct working, then you didn't get any marks. Okay, so we've got a quadratic graph. Our minimum point's 3, 4. So when we've got a -4 in the bracket, that tells us we've got a horizontal shift and it's going to the right because it's a negative value. So if we've moved to the right 4 places, then our x coordinate is now going to be 7 and our y coordinate is not going to change. So 3 lots. So this 3 here is going to affect the y coordinate only. So our original was 3, -4, so our x coordinate doesn't change, and our y coordinate is multiplied by 3, so that becomes -12. A half x. So what that does is it the y coordinate doesn't change, it's the x coordinate, and if you remember, if it's a half in here, then it's going to be double the x value. So in other words, you're going to multiply by 1 over this value. 1 over this value is 2. So it would be 6, -4. Ask me about that if you're not sure. I don't know if I explained it very well. Basically, whatever this number is, you're going to divide your x coordinate by that. So 3 divided by a half gives you 6. Right, the curve is translated as a minimum points of 3, 5. So if it was 3, -4, and it's now gone up here to 3, 5, it means it's gone up 9 units. Okay, so it hasn't gone left or right at all, it's gone up by 9 units, and that means that k must be 9. Alright, so this is vectors, n is a midpoint, a, b is p, so this is all p, from a to b, and a to c is q, and a, n, and b is 3 to 1, so this is 4 in total here, so this will be 3/4 p, and this will be 1/4 p. Because it's 4 in total, so 3 of those 4 things are here and 1/4 is there. Right, expressed in terms of p and q, b to d, b to d. So we're going the opposite way around of p. Oh, what about c? C is the midpoint. So these are both q. So opposite to this direction, positive that direction. So -p plus 2q. Or 2q minus 2p. M to n. So m to n. Alright, so we know that BC B to C would be minus p plus q. Where should I write that? So B, B to C is minus p plus q. Okay, minus p plus q. So from B to n would be half of that. So B to n would be half q, p plus a half q. Okay, so that's B to n. But we want to go m to n. So m to n would be 1/4 p plus what we've just found. So m to n is 1/4 p plus -1/2 p plus 1/2 q. Okay, so 1/4 plus -1/2. If you're not sure, let's do it on the calc. A quarter plus -1. Oops. -1/2. So it's -1/4 p plus 1/2 q. State given reasons, 2 different geometric facts relating mn and BD. MNBD. Alright, MNBD. So BD was negative P plus 2Q. And we've got negative a quarter P plus a half Q. So hopefully, you're not necessarily going to see this, but if you've got negative a quarter P and a negative P, then if you actually multiply this one by 4, so 4 lots of MN would be 4 lots of negative 1 quarter P plus Q. 4 lots of negative quarter is negative 1, and 4 lots of a half is 2. So 4 lots of MN is actually equal to BD. And if you remember, what we said was, if you could somehow write these vectors as factors of each other, it means that they are parallel. So we know that they are parallel because BD is equal to 4 lots of MN. I don't know what else they want to say. I guess they're probably the 2 facts that they want. Right, a cone has volume, blah, blah, radius is twice the height of the cone. Okay, so here's your cone. The radius of the base is twice the height. So if I've got my height, then radius is twice the height. So either the height is half the radius, or radius is 2 lots of the height. The radius is twice the height. Okay, work out the curved surface area of the cone. So go back to formula sheet. Curved surface area of the cone is pi RL. So that's pi RL. So that's a slanting thing. Let's quickly skip this. Alright, so the volume is 562.5. So the volume, so 1/3 pi r squared h is equal to 562.5 pi. That means that I can cancel out the pi's. So 1/3 r squared h is 562.5. But if I know that r is equal to 2 lots of the height, then I can say 1/3 bracket 2h squared is equal to 562.5. So all I've done is substituted this information into my formula for the volume of the cone. So that's, I'm going to get rid of my third, so I'm going to multiply this by 3. So that's 4h squared multiplied by h is what's 562.5 multiplied by 3. 562.5 multiplied by 3. 1687.5. 1687.5. So that's 4h squared multiplied by h is 4h cubed. So h cubed is 1687.584. So h is the cube root of that. So that number divided by 4 and the cube root. Oh, I can't see. So I don't want to do that. Cube root of the answer Okay, so it's 7.5. So h is 7.5. And what do we want to know? The curved surface area of the cone. So we need to know L. So we need to use Pythagoras now, because we know that this is 7.5. R is 2 lots of h. So R is 15. So we're going to use Pythagoras to find that. So it's 7.5 squared plus 15 squared. So 7 squared plus... Oh, no. 7.5 squared plus 15 squared equals square root is 16.7705. 16.7705. So pi times r times l. Pi times r times l. Pi times r times l. So that's L multiplied by, oops, pi multiplied by R, which is 15. So 790.292. Oh, I can't remember. Let's snip this. Ah. Oh, didn't read the instructions. 3 sig fig. 790.